Okay, looking at number five, so how many positive integers? So what I know about n, n is a positive integer. I know that much. Right? What does that mean? Like 1, 2, 3, blah, 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 blah. All right? So what I'm going to do over here is I'm going to make some attempt to factor this problem over here. Again, I'll get to the bottom of the question later, but right now I'm kind of wondering what the prime numbers are. Right, for how many positive integers n is n cubed minus 8n squared plus 20n prime. So I want to make this thing prime. And one way to do that is just try to factor the problem. And I'm going to say this is a function of n, where n is a natural, I'm sorry, where n is a positive integer, or a natural number, I should say, too. So the first thing I do is probably just do, I don't know, try to make a guess at a root of it. And I'm going to say f of 1. And what you get there, you get 1 minus 8. I'm using the rational root theorem, by the way, plus 20 minus 13. And 1 minus 8 is minus 7. And 20 minus 13 is 7. And that does give me 0. So I know f of n factors now. And the root's 1, so the factor is n minus 1. Now the question is, what's over here? It's certainly going to be quadratic, all right? I certainly know it's going to be n squared. And looking at the end of it, I know it's going to be 13, and that's going to be plus 13. I don't know the internal part, though. We could equate coefficients. I'm going to do it by long division, though. So n minus 1, n cubed minus 8n squared plus 20n minus 13. Well, let's take a look. N squared, I was expecting that, right? N cubed minus n squared, subtract minus 7n squared plus 20n minus 13. The other expectation of the remainder is going to be 0. And if it's not, I know I made a mistake somewhere. Minus 7n. I know this is minus 7n now. Let's keep going. Minus 7n squared. And then you're going to get plus 7n. Subtract, you get 13n minus 13. That's going to be plus 13. As expected, by the way. I was expecting that remainder 0. Everything expected. Now looking at this over here, I got troubles, don't I? Let me write this over here. So this polynomial, n cubed minus 8n squared plus 20n minus 13, I got it factored into two factors now. N minus 1, n squared minus 7n plus 13, all right? Now what I know about this guy over here, it's prime. Right, I know that much. So then the question is, what would make that prime? I probably should have went to the whiteboard to do this, by the way. So let's think about it. And I'm going to say, if it's a prime number, one of these factors must equal 1. And I hope you realize if it equals 1, what number would make this equal to 1? It would be n equals 2. All right? So if n equals 2, and again, I got to check this out, by the way. What do you get over here? You would get 1, because 2 minus 1 is 1. Just check to see if it's prime, by the way. And what do you get over here? You would get 4, maybe going too fast here, minus 14 plus 13. And I want to verify this is prime, by the way. If it's not, though, I can't say n is 2, by the way. So let's take a look at that. You'd get minus 10 plus 3, which is 3. And 1 times 3 is 3, which is a prime number, all right? Now, I also want to say, you know what? This could be 1. I'll write that down. So n squared minus 7n plus 13 could be 1. Let's see what we get over there. We get n squared minus 7n plus 12 equals 0. That looks like it's factorable. Again, I'm hoping for integers, right? And what do you get there? Looks like 4 and 3. So I'm going to say I have two other candidates to try. I'm going to say n equals 3 is a possibility, and the other one is n equals 4. All right? Let's put that down, see what we come up with. And you're going to get what? Again, we're checking it here. I want to make sure it's a prime number. 3 minus 1 is 2. But it may seem ridiculous to you, but I know that other factor is 1. Why would you just verify it's 1? But let's go through that anyway. you get 9 minus 21 plus 13. And let's see, 9 minus 21 is going to be minus 12, and minus 12 plus 13 is 1. And this is a prime number, as expected. Let's just run over here. We get 3. And again, the 4, I know it's going to evaluate the 1, but let's go through that. 16 minus 28 plus 13. And 16 minus 28 is minus 12, and minus 12 plus 13 is 1, and 1 times 3 is 3. So what do we do? Let's go back to the original question, by the way. For how many positive integers n is this thing prime? Well, we found them. What do we found? For 2, for 3, and 4. Those are the positive integers that make that thing prime. All right? So if it makes it prime, what is going to be? The answer going to be here. 3 positive integers to make this thing prime. And we're done. Thank you.